Let's do 1.3 day 2 together. The problems that we will complete today are 7, 9, 27, 29, 33, 45, 46, and 47. So this would be number 7. So I know that the function is p of x is equal to 3x plus 4. I'm saying, how does this function change on the interval to 2 plus h? So the average rate of change is always the change in y over the change in x. Or here, it's the change in p over the change in x. So I'm going to take p at 2 plus a little minus p at 2 divided by 2 plus a little minus 2, because we know h is just a small number, a little. Notice how these 2's cancel out and give us just h. But now what I need to do is figure out what p plus 2 is. So I come over here to my scratch work and plug in 2 plus h into p, but p is just 3 times whatever you give it plus 4. So 3 times whatever I give it plus 4, I give it 2 plus h, because that's what I'm plugging in. So then I distribute 3 to get 6, distribute 3 to get 3h, but I still have the plus 4 hanging out at the end. And so 6 and 4 turns out to be 10. So I have 10 plus 3h. So that means this is equal to 10 plus 3h, and so I can replace this with what it's equal to. But then minus p of 2. Well, what is p of 2? Well, p, if you plug in 2, is the p function. Plug in an input of 2, and you get that 3 times 2 is 6, and then 6 plus 4 is 10. So p of 2 is simply 10. I can replace this with what it's equal to. Then I distribute in my negative to get negative 10. That's great because the 10's cancel out, leaving me with 3h over h. But then those h's cancel out to leave me, excuse me, with 3. And that's number 7. Sorry, I needed some coffee. So number 9. This would be number 9. Now I want to know, how does this function change? What is the average rate of change from the point x to the point x plus h? So it's going to be my change in f over my change in x. In other words, f at the second point minus f at the first point over second point minus first point. The x's cancel out just to give me h on the bottom. So then I come over here to my scratch work, do a little bit of scratch work over here on the side, and I see that f of x plus h just means you take the f function, which is 2 stuff squared plus 1, and just plug in x plus h. But what it means to be x plus h squared is you just take x plus h times itself. Let me write that out a little nicer. So it's going to be x plus h times x plus h. So it's 2 times. Well, this gives you, if you FOIL it out, x squared plus 2xh's plus h squared. Well, then I distribute through this 2, and I get 2x squared plus 4xh plus 2h squared plus 1. And so now, anytime you ask for f of x plus h, I can replace it with this quantity. So that means everything in yellow gets replaced with this. But then they want us to subtract f of x, but I know that that's just plugging in x into my f function, which I already know is 2x plus 1, 2x squared plus 1, so I can just put it in right here. You want to be really careful. It's all of this minus all of this, so I need these big brackets, a chunk minus a chunk, and then I very carefully distribute through the negative to hit both of these, and it turns both of those into negative 2x squared minus 1. Well, now I see that I can cancel out my 1 and negative 1, my negative 2x squared and positive 2x squared, and all over h. Notice, all of my equals line up nicely. It's very easy to read. I didn't get lazy and just randomly drop off my h. It's still there. Really good quality work. So here, then I notice I want to be able to cancel out this h on bottom. So I factor out an h out of everyone. And so that allows me to look at the bottom, cancel out that h. Because we've just multiplied and divided by h, that's the same as multiplying by 1, and you're just left with this. Right? Should that be 4x squared? This should just be 4x, excuse me. This shouldn't be x squared. This should just be 4x, right? All right, so that's 9. Let's now look at 27. So let me go back and put in 27. So if you ask me to do 27, I'll look online, and 27 is a table. So it says between, let me take a picture for you so you can follow. So if this is, clear that up for you, there's 27. So it wants to know what is the average rate of change from 2002 to 2004, okay? 2002 to 2004. So I'm going to crop this thing, and from 2002 to 2004. Okay, so it wants to know the average rate of change from 2000. So in this case, our population is P, and our time will be our years, right? So we're going to find P. If I want to go from 2002 to 2004, I'm going to do P of 2004, that's the second value, our second x value, minus P at 2002, that's our first x value, over 2004 minus 2002. We see how this is just the average rate of change. Bloop, 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 bloop. Average rate of change, because it's simply the change in my outputs over the change in my inputs. So the change in my inputs is just 2 years. But what is P at 2004? Well, at 2004, our population is 77,000 minus. At 2002, it looks like our population is 83. So it looks like our population has gone down, so I would expect a negative number, which I do. I get negative 6 over 2, which is negative 3,000 per year. Because notice, it is 1,000 people. Notice the units for the top are 1,000 people, and the units for the bottom are years. So our average rate of change from 2002 to 2004 is about negative 3,000 people per year. So that's 27. And if I can duplicate that page, I need to do the next part of this problem. It wants me to find the same sort of a thing, but just different values. So let's see where it's talking about. In the second part of the question, it wants us to find the average rate of change from 2002 to 2006. 2002, 2006. So 2006 would be our second year minus 2002. And the denominator would be the change in the inputs. So the inputs have changed 4 years. P of 2006 is 78. P of 2002 is 83. So what's that? That's going to be negative 5 over 4, right? So that's going to be negative 5,000 people every 4 years, right? But we know that if you take 5 and divide it by 4 in decimal form, yeah, it's just 1 1/4. Duh. So this is negative 1.25 thousand people every year. In other words, we lose this many thousand would be that many people per year. We lose, on average, about that many, 1,250 people every year. So that's 27. Now let's do 29. So let me add one before this. So 20, I meant to do it before it. Let me take this, move it over here. So let's do 29. I'll do a different color. 29 is find the average rate of change of the function. So if h of x is equal to 5 minus 2x squared on the interval from -2 to 4, it's going to be the change in h over the change in x. So it's going to be at 4 minus what you get at -2 over 4 minus a -2. So how far is it from -2 to 4? It is 6 steps. But then h of 4 is just plug in 4. So it's going to be 5 minus 2 times 16, or 5 minus 32, which is -27. So this is -27 minus h of -2 would be 5 minus 2 times -2 squared. That's 5 minus 2 times 4, which is 5 minus 8, which is -3. Notice how carefully you have to be with these signs. So this is -27 plus 3 over 6, which is -24 over 6, which is -4. Right? That's 29. And then 33, this is my ugly function, and I want to find the average rate of change on this interval. So this is going to be the change in p over the change in time. So it's p of 1, and I want to be really careful about this and make sure that I haven't made any silly mistakes. So I'm going to go back and do it again from the very beginning. So making sure I'm reading the function right, it's t squared minus 4, t plus 1 over t squared plus 3. So that means I'm first, if I want the average rate of change, I'm going to first plug in 1 minus plug in -3 over, it's -3 to 1. So it's 1 minus -3, which is 4, because that's how many steps it is. So then over here in my scratch work, I'm first going to plug in 1. So it's going to be 1 squared minus 4 over 1 plus 1. It's going to be 1 squared plus 3. So I should get -3 times 2 over 4, which is -6/4. Then I'm going to do p of 2. So that means that p of 1, not p of 2, why did I say 2? I think that's why I screwed it up. So this is -6/4, right? Minus, now I'm going to do p of -3. So I'm going to -3 gets squared minus a 4. We take -3 plus 1 over -3 gets squared plus 3. So on top, that's going to be 9 minus 4, which is 5. It's going to be -3 plus 1, which is -2. The bottom, that's 9, 10, 11, 12. That's 12. It's -10/12, which is, if you take out a 2, -5/6. So it's -6/4 minus 5/6 over 4, right? Okay, let's be careful. So what I'm going to do now is I'm going to combine those fractions on top by using a well-chosen 1. I'm going to hit that with 3 and 3, and this with 2 and 2. So it's kind of going backwards a little bit. I guess I should have just left it, but whatever. So that gives me -18/12 plus 10/12 over 4, which is -8/12. Divided by 4 is the same as multiplied by a 4th. These cancel out, give you -2 over 12, which is -1/6. And if we look at 1 and divide it by 6, then you get, oh poop. If you take 1 and divide it by 6, you get 0.16 going on forever, which for number 33 is the answer that we should expect. Okay, they just rounded it. Cool, great work. So that's number 33. Now I need number 45. 45. I've got a driver. Car stopped at the gas station. They look at their watch, and the time is 3:40 p.m. At this time, they start pumping gas. At exactly 3:44, the tank was full, and they had noticed. So 1 point on our graph is 3:40 p.m., comma, nothing, right? Just imagine it had no gas in it. It doesn't matter how much it had in it. I could say it had some initial amount, G for gas, right? And then at 3:44, it had that amount of gas plus 10.7 gallons, right? So what I want is the change in gas divided by the change in time. So the change in time is going to be 3:44 minus 3:40, which is going to be 4 minutes. But on top, it's going to be the amount of gallons we had plus 10.7 minus the original amount of gallons. It's going to be 10.7. So in other words, the change in gas was 10.7. You could, yes, just jump right to here. And the change in time is 4 minutes. So 10.7 divided by 4 is, remember this is gallons. We were putting in about 2.675 exactly gallons per minute. That was the rate at which it was going in. That's the average rate of flow of gasoline into the tank. Notice how important the units are. Number 46. So 46 is near the surface of the moon when an object falls. Its d of t is equal to 2.6667 t squared. So notice it's not distance an object falls in time. It's this. Okay. If an object is dropped from a certain height, find the average velocity from 1 to 2. So we know that average velocity, 2.667 t, so that's a 7, not a greater than. 3 6s is 7. Okay, so they want to find the change in distance over the change in time. That's going to be our average rate of change. But when it's the average rate of change of distance, that's the same as velocity. That's what they mean. So change in d over change in t is average velocity. Those are the same thing. Note. So the average rate of change is going to be d at, well, the second point is 2 seconds minus d at 1 second over 2 minus 1. So on the bottom, I get 1 second. But on the top, come over here on my scratch work, and I do d of 2. It's going to give me 2.6667 2 squared. And then I do d of 1 is just going to give me 2.6667 with a 1 squared, which is just 1, right? So I can make that go away because it's just 1. So I'm going to get this times 4 minus this times 1. So if you take that out, it's going to be 3 of these things, right? It's going to be that many, feet? Yeah, it's going to be that many feet per second. That many feet every 1 second. It's going to be what? 2 times 2.6667 is approximately 5.3334 feet per second. Cool. Again, you could have gone from right here. I just noticed if you have 4 of these minus 1 of these, then you have 3 of these. That's all I did. Cool. That's 46. Great work. Let's look at 47. You are so almost done. 47 is a graph. says use the graph to find the average rate of change. Find the average rate of change from 5 to 15. So if this is my graph and I crop it from here to here to here, and I say done, okay, so from 5 to 15, well, at 5 days, so at 5 days, it looks like I have about 13 milligrams of this material. And at 15, it looks like I have 6, right? That's pretty close. It's pretty flat. So we are going to do the average rate of change is going to be the change in the amount over the change in time. So that's going to be A at 15 days minus A at 5 days over 15 minus 5. Well, the change in time was 10 days. And then I come up here on my scratch work, say, look, oh, I don't need any scratch work, dude. A of 15 we just said was 6 because that's the output you get. And A of 5 was 13 because that's what you get. So it's going to be about -7 over 10 days. The units on top are what? Milligrams. So it's going to be about -0.7 of a milligram per day. Great work, and I will see you in class.